Welcome to EDU World Space.
Hello. So in this problem, we're asked to figure out the energy loss from the result of several collisions between vehicles. So I'll just do a little rudimentary drawing of what happened here in our problem. So along some road, we have a series of cars. I'll draw them as circles here. I believe we have car A here, then car B, and car C. Car A and B are initially at rest, so we have a velocity of 0. And car C is heading in at a roughly slow speed. I believe it's 1.5 meters per second. So, of course, what happens is car C collides with car B, then car B collides with car A, and we just have a little chain reaction of impacts here. Now, a previous problem has us figure out all the final velocities of these cars after the impacts. So afterward, after all is said and done, right after C has hit car B and B has hit car A, we have car A heading to the left at a velocity of 1.013 meters per second. And that is from solving a previous problem. We have car B traveling at a velocity of 0.338 meters per second. And car C ends up traveling at a velocity of 0.150 meters per second. So in this problem, we just need to figure out how much energy is lost after all of these collisions have occurred. And so remember, to figure out how much energy we lose in two collisions in a system, we just need to take into account and think about what is the change in kinetic energy of our system. So all of that energy we lost due to non-conservative forces at work, sound being created, friction rubbing, two cars impacting each other and crumpling, right? All this energy can be determined by figuring out what is our change, our delta T, our change in kinetic energy. So we got to figure out what is our total kinetic energy after all of the impacts, our final kinetic energy, and then to compare that to the initial kinetic energy we have before all the impacts, right? So at the end, after all the collisions have occurred, what is our final kinetic energy? Well, it's going to be the sum of all the kinetic energies of our cars. And we've been told that all of them have the same mass. So car A has just mass m, and the energy it has is going to be given by 1/2 the mass of car A times its velocity, final velocity squared, right? So we have that contribution to the kinetic energy from car A. Then we have the contribution to the kinetic energy from car B, 1/2 m times velocity b squared. Then we have the contribution to the kinetic energy of car C after the impact, right? So this is our velocities of these velocity A, B, and C are the velocities of our cars after all three impacts have occurred. And then we add up 1/2 mv squareds individually, and that's going to tell us what the total kinetic energy is after the cars have collided. Now, we then have to subtract off the initial kinetic energy before any of the impacts occurred. And so what energy do we have there? Well, again, car A is not moving. Car B is not moving, but car C was moving at 1.5 meters per second. So the total kinetic energy before the collisions comes purely from car C, which again just has a mass of m. They all have the same mass, and multiplied by, we'll just call this v. We'll call this velocity v here. So the 1.5 is just represented as that velocity v without a subscript. So we actually have all these numbers except for the mass. So I think this is an updated version. I think they updated the book problems without thinking about the problem they were referencing. And so they actually weren't given any car masses in this problem. So instead of being able to report the energy loss, we're actually going to only be able to report the energy loss per unit time, right? Because you see all these masses are the same. So I can actually pull it out of my equation. So I'm going to pull out all my masses. And even actually the 1/2 as well. And then what I'm left with is my final velocity a squared plus final velocity b squared plus final velocity c squared minus my initial velocity v squared. So this is what I have, and I have my mass out here. So I'm going to divide my mass out and put it over on the side of my equation that's for the variable representing the energy loss. So in the end, what I have is that the energy loss per unit mass is given by 1/2 of the final velocities all squared and added together after all the impacts have occurred. And then subtract, let me undo that last parentheses there, minus the initial velocity of car C squared, right? If I plug in all these numbers that I've given up here into my calculator, I'll see that I get an answer of negative 0.54. Let me write that a little better. 5.4. One of the units of energy per kilogram, energy per unit mass, joules per kilogram. And that is our answer.